Okay, so the last thing you need to know about vertex form is what that stupid A does that's in the front. Okay, so we already covered that the K makes you move up or down. If it's plus, you go up. If it's down, if it's negative, you go down. The H makes you move right and left. If it's minus, you go right. If it's plus, you go down. Or sorry, left. Then is the A. Now notice the A is on the outside, okay? So that means it's going to be a vertical change, okay? Because it's on the outside of the parentheses. So the A can actually make you do two different things. The A can make you do what's called a vertical stretch. Can't spell. Or vertical shrink. And that comes from whether the A value, and we're not caring about whether it's positive or negative, so we're going to call it the absolute value of A. We care about whether that number is larger than 1 or less than 1. So if the absolute value of A is larger than 1, that makes you do a stretch, and it makes your graph get like super tall and skinny. Think of like someone taking a piece of bubble gum and stretching it out, okay? If the absolute value of A is less than 1, so like example 1/4, 1/2, that's going to make the graph, it's going to make the graph get short and fat. So pretend that like somebody took their foot on the graph and like squashed it down, okay? So let me show you an example of each so that you can see what it's going to look like here. And I'll show it to you with no shifting, just so that you don't get confused by the shifting, okay? All right, so let's look at one that's going to end up being a stretch. And then let's look at one that's going to be a shrink. And some people call it a compression. And remember, these are vertical, okay? Okay, so if you want to stretch, the number that's going to go outside of the x squared in front of it, the coefficient, is going to be bigger than 1. So let's look at like, the easiest one they always show you is 2, just because they get really big really fast. Okay, so keep in mind, normally, your parent function would have had a dot at 0, 0, 1, 1, and 2, 4. And then the reflection on the other side of the axis. Okay, so this black graph is your parent. Okay? So normally it would have been 0, 0, 1, 1, 2, 4. Okay, but I just did a vertical stretch, which means I took all my y values and doubled them. So now I'm going to have a dot at -2, 8. And at -1, 2. Double of 0 is still 0. 1, 2. And 2, 8. Do you see how my graph looks like tall and skinny now? That's because of that A value in the front. The absolute value of 2 was greater than 1. Okay? You can also make it shrink by putting a number in there that's less than 1. And remember, it's the absolute value, so you're not looking at the positive or negative right now. Okay? So again, if that was the case, my parent would have normally had these points. But because of that 1/2 in the front, I'm going to make them half as big. So instead of the point -2, 4, I'm going to have the point -2, 2. And instead of the point -1, 1, I'm going to have the point -1, 1/2. Half of 0 is still 0. Remember, these should be symmetric. So it should look like you took the black graph, which is the parent, and just squashed them to the ground. You made them half as big. Okay? I'm going to start a new page for you. Okay? Last thing they can do to mess with you, other than moving you up and moving you down and moving you right and moving you left and making you stretch and making you shrink. The last thing they can do is give you a flip, okay? And again, a flip is also called a reflection. Your teacher might die if you call it flip. Okay, but this is also related to that A value. If the A value is a positive number, then your graph is going to open up like a cup. If your A value is a negative number, your graph is going to open down like a frown. Okay? So I can show you a real simple one. If I just had the basic graph, y equals -x squared, that's going to take my parent, which looks like this, and it's going to make him flip over the x-axis. It's going to make him flip upside down. So it's going to be a reflection over the x-axis. And I'll have this red graph that goes down like a frown. And that's because my A value, which they don't write the 1, was technically a -1. Now, if they wanted to be tricky and they said, is this graph vertically stretched or shrunk? No, because 1 is the normal number. So if your A value is a 1, it's not stretched, it's not shrunk, it's normal. Okay. Depending on how mean your instructor wants to get, they can mix them all together. So let's go nuts. Let's say that I have y equals -1/2 x minus 4 squared plus 6. I don't know, I'm just making stuff up, okay? So first thing you got to deal with, inside you have that -4. That means you are going to shift right 4, because remember, it lies to you when it's on the inside. If you see a minus, you're actually going in the positive direction. Okay? Then I've got this 1/2 dude over here. So I'm going to vertically compress by 1/2. I've got this negative in the front. I'm going to reflect over the x-axis. And then I've got this +6 on the end. That is going to shift up 6 spaces. So if they asked you what your vertex was, you can see the vertex just by looking at the equation. The x value of your vertex is inside, and it's the opposite of what you see. So if you see -4, the x value of your vertex is +4. The y value of your vertex is on the outside, and it doesn't lie to you. So if I see 6, I'm going to have a +6. Now, if you're freaking out, you're like, oh my God, I don't know how to graph this, don't freak out. You're going to pick points, okay? So we know what it's going to look like already, but I'm going to make myself a little t-table. I'm going to pick my vertex and put it in the middle. I know it's 4, 6. I'm going to pick the numbers that are on the right side of 4. I'm going to pick the numbers that are on the left side. Oops. Left side of 4. Now keep in mind, because of symmetry, the answer you get for number 5 and the answer you get for the number 3 should be the same because of symmetry, because they're equally spaced from the vertex. Okay, so let's plug my 5 in there. So if I did 5 minus 4, that would give me a 1. And then I'm going to square it, which would still give me a 1. And then I'm going to multiply it by negative 1/2. And then I'm going to add 6. Okay, well, 1 plus times negative 1/2 is negative 1/2. And if I added 6 to that, I'd be at positive 5.5. Okay, then I'm going to deal with the 2 and the 6. And remember, they should give you the same answer because they're equidistant from your vertex. Okay, so I'm going to plug in my 6. Negative 1/2 times 6 minus 4 squared plus 6. Okay, so 6 minus 4 is 2. 2 squared is 4. Negative 1/2 of 4 is negative 2. And negative 2 plus 6 is, 4. Okay, so let's graph that. Let's see what it looks like. Remember, it should look like it's right 4 spaces, up 4 spaces, upside down, and squatty. I'm going to plot my vertex first. Then I'm going to plot the numbers on each side. Not perfect, but there you go.